So this is Lab 3 presented by myself, Krish Patel, regarding the magnet and the bar. So experiment purpose. The overall goal of the experiment was to utilize a physical calculation as well as a computerized model in order to do the following. First, determine distance dependence of the magnetic field from a magnet. Secondary, to measure magnetic field on the magnet using the Biot-Savart law. And lastly, to compare and contrast from the physical calculated model and the computerized model, which we will use GlowScript for. Continued purpose. So here we'll go into the overall results from the study experiment. Magnitude of the magnetic force decreases with an increase in distance, so they have a negative correlation with one another. The calculated magnetic dipole moment was 1.4657, and the measured off-axis magnetic field using the equation was 6.97 e negative 5 teslas. Computerized model of the off-axis magnetic field 9.222 e to the negative 40 teslas. Now this is an important number to mention because it was derived from the computerized model, and it was later determined that the computerized model was wrong, and therefore this answer is not correct, as can be pretty evident. Laws utilized. So the primary law that is utilized in the experiment is the Biot-Savart law. The intent and purpose of this law is to relate the magnetic field from an observation point to another object and be able to determine the distance of said magnetic field. So here is the law continued, just to kind of describe the law and what everything means, and how we'll be using it in the actual experimentation. So if you look here, you have the distance, you have the radial directions, the segment. Now all of these things can be filled in once we find that distance between the bar magnet and the little magnetometer. Other incorporated B dipole perpendicular law, as well as the magnetic field of a dipole formula that we'll have to derive. Here is the kind of figure of the magnetic field on that bar magnet object, so you can see all the arrows kind of gravitating towards the center of the bar magnet. This experimental procedure, the bar magnet utilized to measure the distance between it and the measuring magnetometer. 20 to 200 teslas is the range. Off-axis measure utilizing the distance in the y direction with correlated movement of the magnetometer. Computerized models for comparison using the provided code. The computerized model was not reflective of the appropriate correlation between the physical depiction of experimentation. Therefore, code is not displayed and will be considered an error in experimentation. Findings. I did find that as the distance increases, there's a correlated decrease in the magnetic field strength. Again, here's the calculated numbers that we went over in the first slide. Errors. So the first is the error in the coding. Somewhere in my coding lines there's a malfunction and returned a very abnormal for my off-axis calculation. Another is inconsistency of placement of the magnetometer, as my hand was holding it and consistently moving during experimentation. Furthering experimentation, for the next level, I would use a more appropriate magnetometer device compared to my phone. Another thing I would use is a larger bar magnet when compared to the very small one I was able to use. That's it. Thank you all for watching.